6. What counts as a good explanation? A neat formula is not the only kind of understanding. For three bodies, an explanation can be qualitative. Sensitive systems stretch and fold trajectories like taffy. That is why tiny differences grow. Geometric, show the shapes of motion, loops, horseshoes, resonances, and how they connect. Statistical, give the distribution of lifetimes before ejection, or the fraction of time bodies spend in certain zones. Philosophy sets these standards. Experiments and simulations meet them, or force us to revise them. 7. Quiet success stories. Not everything in the three-body world is disorder. Philosophy suggested looking for shared frequencies and balance points. Experiments confirmed them. Resonances. Some triples lock into repeating ratios of periods. This framing came from simple questions about symmetry. Telescopes and simulations found real systems that do it. Lagrange points. Theory predicted 5 special spots in a two-body setup where a third small object can balance forces in a rotating frame. Spacecraft now use these points as parking spots. This is philosophy drawing a map. Engineering follows it into space. 8. The deeper debate. Does science begin with ideas or with data? The three-body problem says the debate is a false choice. Ideas without data drift. Data without ideas drown. We need both in rhythm. Begin with clear questions. Philosophy. Build models that capture the core and ignore the noise. Theory. Measure where the model is blind. Experiment. Compute to explore the middle ground at scale. Simulation. Update the questions based on what breaks. Philosophy again. This loop is how science moves when the world is lawful but complex. 9. What the three-body problem teaches beyond astronomy. In climate, small changes can shift patterns. We forecast ranges and tipping points, not exact weather months ahead. In engineering, we test structures and control systems across many possible nudges rather than trusting a single perfect calculation. In biology, we accept that ecosystems can be stable yet fragile. We model flows, feedbacks, and risks, not just averages. The lesson carries: demand explanations that admit uncertainty and design experiments that measure it. 10. A simple answer to the title question. Should philosophy guide experiments, or should experiments guide philosophy? The three-body problem answers both in turns. Philosophy frames the hunt. Experiments set the bounds. Computation connects them. The result is not a final formula for everything. It is a reliable way to learn in a world where small causes can grow big effects. We do not escape chaos. We work with it by asking better questions, looking carefully, and letting each approach correct the others. Summary. You can hold in one picture 3 orbiting dots. A tiny nudge, and their future branches like a tree. Philosophy says, what counts as understanding? A line, a shape, or a probability? Experiment says, here are the branches we can actually see. Computation draws the forest. Science is the whole picture.